Let us move on to the last topic of the session, which is debugging. Debugging simply means removing bugs or errors from the code. So these errors can be broadly classified into two categories. The first category of errors are called as the syntax errors. So these syntax errors occur when the programming language rules are not followed. Every programming language like Matlab has its own format of writing the code, and if that format is not followed, then Matlab is going to throw a syntax error. These errors are identified by the coding tool itself, though at times the error description might be misleading or a bit vague in a way that's actually not that useful to debug. The examples for syntax errors are listed here. If we look at this statement, A is an array of 5 elements, and we're basically calling the 0th element of A. This statement is going to result in a syntax error saying subscripts must be integers. In Matlab, indexing of the array starts with 1. So there is no 0th element, right? So the first element is A of 1, the second element is A of 2, third element A of 3, and so on, which is unlike C++, where the first element can be accessed by writing A of 0. So in Matlab, this is not going to work. The second statement here is going to lead to a parse error because we're missing a closing square bracket here. So whenever we miss a square bracket or any bracket, or there is a mismatch in bracket, that usually results in a syntax error called as a parse error, where the code is not able to interpret the statement. So this is usually caused by missing closing parentheses or square bracket. The third example here, we have an array A, and we want to compute the square of A. So this operation again is going to result in a syntax error, which says incorrect matrix dimensions, because by default, so we all know that Matlab is going to treat any variable as a matrix. So when we do any computation like A square, Matlab is actually trying to perform matrix multiplication. And to perform matrix multiplication, we know that the number of columns of the first matrix should be equal to the number of rows of the second matrix. Only then matrix multiplication is possible. So in this case, since that's not true, this will result in the following syntax error. So here, since we don't intend to do a matrix multiplication, we intend to do element-wise squaring operation. So this can be resolved by just using an element-wise operator. The second type of errors are called as the logic errors. These errors are a result of incorrect implementation of program logic. We know that our code has logic errors if the code does not produce the expected or intended results. So these errors cannot be identified by the code. So the user has to put effort in identifying these errors. A very common strategy to spot these errors is to run the code line by line or one small section at a time and check the output. In addition to that, we can also make use of the debugging tools available in Matlab. Matlab lets us add breakpoints along with other options to basically run the code line by line or a small section at a time and analyze what is actually happening and how the code is interpreting each line. So we'll be discussing all these options very shortly in the demonstration. Now let us understand how we can use Matlab's debugging tools to spot logic errors and rectify them. The basic idea of debugging is to run the code one line at a time or one small section at a time and check corresponding output and if the control flow is correct. So the breakpoints in Matlab are going to help us in doing this. These breakpoints can be used to pause the program execution at any point inside the code. We've already used breakpoints, if you might remember. To use breakpoints, one can simply click on these dashes corresponding to each line of code. So if I have to place a breakpoint on line number just 7, so I simply click on the dash corresponding to that line. And when I hit the run button, the control is basically going to stop here. It's going to pause in this line, right? So what has happened is the Matlab executed all the lines before this point, line number 3, 4, 5, 6. It's going to execute all those lines, and the control has stopped at line number 7. So this line hasn't been executed yet. As you can see in the workspace, if this line would have been executed, then the variable n and its value would appear in the workspace. So you can notice that few additional options become active in this region. These options are very helpful in navigating through the code when in this debugging mode. So let us learn what each option does. Clicking on continue is going to run the code until it encounters another breakpoint. So if I click on continue, since there is no other breakpoint, the code is going to run entirely, right? The code is going to run. You can see the output, which says the number is prime. Now, if I place another breakpoint, let's say here, and if I run the code, first it's going to encounter this breakpoint, and the control is going to stop here. And then if I continue, it's going to stop here in line number 19. And if I click on continue again, the last line is also going to run. Now, again, let us go back to the debugging mode. Now, step option is used to run code one line at a time. If I click on step icon, it is going to run line number 7, and the control is going to move to line number 9. Right? So now you can see that line number 7 has been executed. The control is in line number 9. So this green arrow represents the point where control is paused currently. Step in and step out basically are they have the same functionality as step. So step in is used to step into a function, and step out is used to run the entire code inside the function and then return the output to the main code. We can actually visualize this with the help of a function example. So let me quit the debugging mode here. I'll first clear all the breakpoints. But this is a code where we use a function to check if a number is even or odd. Let us place some breakpoints here. Now, when we run the code, you can see that the control has paused in line number 6, right? So now when I click on step in, it's going to step inside the function, right? So which is the odd or even function, right? Now, when I click on step out, it's going to run the entire function code, and the control is going to flow back into the main code, right? So I can actually keep using step here, right? But when I click step out, it's going to run the entire function code at once, and the control is going to return back to the main code, right? And I can use step to basically run each line at a time or the entire code at once. Now let us move back to our original code. Let us clear all breakpoints. Let me place a breakpoint here once again and run the code. That leads us to the last option, which is run to cursor. So what this means is, let's say I place my cursor here in line number 19 and I use this option. It's going to run the entire code until the line where my cursor is pointing, right? Or where my cursor is located, and it's going to stop there. That is what this option does. Now, let me clear all checkpoints. This is a code to check if a number is prime or not. So you can see that we've checked for a prime number, and this code seems to work fine. Let us try other prime numbers as well. Yeah, so for all prime numbers, this code is working fine. Now this code contains an error. The moment we give it a number that is not a prime number, the code does not function as expected, right? The expected output would be that we get an output that the number is not a prime, and then this line, right? So here we can actually use these debugging tools. So use the step function and run the code one by one and try to figure out what the problem is. Let me place a breakpoint here and run the code. So I'm going to use the step option to debug this code. Let us run the next line. In the first iteration, we can see that the I assumes a value of 2 and n is 10. So here, this condition is going to evaluate to true and the control is going to go inside, right? And since n is not equal to I, so this condition is going to fail and the control is going to go to the else branch where it's going to print that the number is not a prime. Until now, the code is going fine. Now, if I click on the step option again, okay, so it's going to end this if structure. And if I click on the step option again, okay, it's going to come here, which marks the end of the for loop, right? And I click again, it's again going back. If I click the step option, now it's not going inside this if structure because 10 is not divisible by 3. And click on the step option again. That will take us to the end of the for. And clicking on it again. So now you can see that the value of I is 5. Clicking on this, running this line. Now the option is going to be true. The control is going to go inside this if branch. And since the condition is false, it is directly skipped this part and the control is moved into the say else block, right? Now it's going to print this again, and this is going to continue until I is equal to n. Now this code should have ideally stopped at this stage itself. As soon as we found out that okay, 10 is actually divisible by 2, there was no necessity to keep running the for loop, right? Now that is the reason, since we kept running the for loop even after finding out the number is not a prime, so that is why it is printed so many lines. Now to fix this, what we should have done is as soon as we find out that a number is prime or not, we need to immediately stop the for loop. Now how can we do that? We can use a break statement to abruptly end the for loop. So what we're doing here is as soon as this particular number is divisible by I, as soon as n is divisible by I, now there are only two possible cases. The number can either be prime or it can be a non-prime, right? Once we decide if it's a prime or not, we immediately break out of the for loop. Now this will stop the iteration. We can actually run the code and see if it works. Now, if we run the code, yeah, so you can see that now this is correct. In addition to this, whenever we're in the debug mode, if you look at the command window, you can see that so there is K there. K basically stands for keyboard. In this mode, the command window is still functional. We can still use the command window to perform regular operations, right? But what we need to note is that whatever operations we perform here is going to affect the working of the code, right? Now let's say my control is at this point, right, where n is already initialized, right? Now here, if I say that n is not 10, n is 20, the value of n is going to change, right? And for the remaining part of the code, the value of n will be 20 throughout, right, and not 10. So any changes that we're doing here or any operations or commands that we run in the command window can possibly affect the working of the code. So please make sure that if you have to use the command window at all, you don't use the same variable names. So hope the idea of debugging using Matlab's own debugging tools was clear. Now let us summarize our learnings from this session. So now we know that inside a code, the control flows from top to bottom and left to right, except when using control structures. And control structures basically refer to statements that are used to manipulate flow control. Examples are if else, for, etc. We learned about pseudocodes and flowcharts, which are tools that can help us form a clear and concise idea of the programming logic before creating the actual code. Pseudocodes are more suitable for larger codes, whereas flowcharts are more suitable if one wants to clearly understand the flow of control inside the code, and also for debugging. And one might use either of the pseudocodes or flowcharts, or both, depending upon the necessity. We learned that there are two types of errors: the syntax errors and the logic errors. Syntax errors are identified by the code and are easier to resolve because the coding tool itself is going to point out these errors. Logic errors are not identified by the code, so they're not so easy to resolve. Matlab's debugging tools can be used to identify these errors and rectify them. And from the learnings of this session, you'd be required to attempt a few challenges that are going to help you build logic. So you'd be using pseudocodes and flowcharts to develop the logic. You might also need to use Matlab's debugging tools if you run into syntax or logic errors. Please attempt the challenges honestly and reach out to us in case you have any doubts. So this is the end of the session. Thank you for your time.